The origins of the universe have been a subject of human curiosity for centuries. The prevailing scientific theory that explains the origins of the universe is known as the Big Bang theory. According to this theory, the universe began as a singularity, a point of infinite density and temperature, approximately 13.8 billion years ago. The Big Bang theory proposes that the universe started expanding rapidly from this initial singularity. As it expanded, the universe cooled down, allowing the formation of matter and energy. In the first few moments after the Big Bang, only elementary particles like quarks and electrons existed. As the universe continued to expand and cool, these particles combined to form protons and neutrons, which eventually formed atoms. About 380,000 years after the Big Bang, the universe became transparent as atoms formed and light was able to travel freely. This event is known as recombination. The radiation from this early stage of the universe is what we observe today as the cosmic microwave background radiation, a faint glow spread throughout the universe. Over billions of years, matter began to clump together due to gravity, forming stars, galaxies, and galaxy clusters. The force of gravity played a crucial role in the formation of structures in the universe. While the Big Bang theory provides a comprehensive explanation for the origins and evolution of the universe, there are still some questions that remain unanswered. For instance, scientists are still investigating what triggered the Big Bang and what happened before it. The nature of dark matter and dark energy, which are believed to make up the majority of the universe's mass and energy, is also not yet fully understood. Furthermore, physicists are exploring various ideas and theories that go beyond the Big Bang. One such concept is inflation, which suggests that the universe underwent a period of extremely rapid expansion in the first fraction of a second after the Big Bang. Inflation helps explain some of the observed characteristics of the universe, such as its overall homogeneity and flatness. String theory and other proposals in quantum physics are also being studied to gain a deeper understanding of the fundamental nature of the universe. These theories aim to unify all the fundamental forces of nature, including gravity, into a single framework. In summary, the Big Bang theory provides our current understanding of the origins of the universe. However, ongoing research and exploration in cosmology and theoretical physics continue to push the boundaries of our knowledge, offering new insights into the early moments of the universe and what lies beyond the Big Bang.